Welcome to CARIS's water column imaging webinar. Just to introduce myself, my name is Matthew Gudger. I've spent the last 3.5 years using CARIS products as a processing lead for TerraSon's Alaska office. I've recently joined the customer support team here at CARIS headquarters in Fredericton as a technical support consultant. So today's webinar will be a review of what's new in Service Pack 1 with focus on implementation of water column imaging into HIPS, followed by a quick review of some other highlights in Service Pack 1. When we look at the evolution of surveying, it all started with a simple lead line, which is extremely sparse data. With the advent of mechanical lead lines, and data density began its growth. With the invention of the single beam echo sounder, data density grew exponentially again. By the time we finally got to multi-beam echo sounder, data density grew exponentially larger again. The data included more than the seafloor that hydrographers were looking for. Sonar manufacturers spent considerable time creating filters to remove data that was not associated with the seafloor. Now with water column imaging, we're going to go back and look at that entire water column trace. The goal of adding water column imaging in HIPS was to allow the user the ability to use water column data as a QC tool for validating bathymetry, and as well as a visualization tool to see things in the water column that we weren't looking at before, such as gas seeps or oil plumes. The implementation of water column imaging will happen in 3 phases for HIPS. Phase 1 was released in February and allows the user to read and display water column data in Swath and subset editors. Phase 2 is currently being implemented and will focus on making ray tracing more robust. Currently in subset editor, we're using a straight line ray trace using 1500 meters per second to create a 3D georeference point cloud. For phase 3, we are looking at some options to create more vigorous filters, calculate volumes, and target least depths. As a HIPS user, one thing I love about our implementation of water column imaging is that if you're currently processing multi-beam in HIPS, you already know the workflow for processing water column data. Simply put, you create your project, convert, load tide, merge, and create a base surface, and now you're ready to start looking at the data in Swath Editor and then move into subset editor. No fancy workflows here, just keep doing what you have been doing. Another thing I like with Service Pack 1 is that there's no longer a need to carry over your raw data files. Not copying this data means less space used when you're processing with HIPS. Seamless integration is what we wanted to achieve when adding water column imaging to HIPS, and that's a great way to describe how it fits into Swath Editor. Water column data is accessed on the fly using background threads when you're opening. With everything open, Plan View will continue to control all the other views, including the 2 new water column views. While Swath Editor may not be included in your regular multi-beam workflow, it becomes a very useful tool in the water column imaging workflow. Due to the vast amounts of data contained in water column imaging, viewing one line at a time allows the ability to narrow your focus in order to target particular intensity ranges that most interest you, allowing you to see this forest for the trees, so to speak. And we'll demonstrate these when we get into the workflow. In Subset Editor, again, seamless integration is the big highlight about water column data. The learning curve for users is almost non-existent. When the data is loaded in Subset Editor, you'll end up with a 3D georeference point cloud that displays with your bathymetric data. The data is loaded using background threads, so you can continue to use subset while data loads. And because there's so much data, you can also apply intensity filters derived during Swath Editor in order to help you focus on the data of interest. As well, you can filter the data by depth and minimum slant range. And now that we've got an overview of water column functionality, let's open up HIPS and take a look at some data. The 2 data sets that we'll be viewing today are research data sets collected by the Ocean Mapping Group at UNB. The first data set comes to us from Grand Bay, Westfall area in New Brunswick. It's about an hour and a half south of CARIS headquarters here in Fredericton. The data was acquired in the fall of 2010, and this particular area of the St. John River was found to contain gas seeps. So if you're a geoscientist or someone interested in resource management, this can be a very useful tool to you. At this point in the post-processing, the files have had tide loaded and they're merged, so we're ready to begin viewing water column data. What we'll do is we're going to select the line here, and one of the other new additions in Service Pack that I really enjoy showing off is the ability to right-click on lines and open all your editors. Let's quickly take a look in Swath Editor. One of the things you're going to notice off the top is the new water column toolbar. First button, Create, it controls your cross-track view, and we'll just quickly open your cross-track view, and what this is showing is the entire water column image for one sonar ping. The next button is your Y button. That's going to control your along track display. On track display here is just showing the nadir beam, and that's the nadir beam from all of the profiles controlled here in your plan view. The next button is going to turn on and off your bottom detection, which would be your bathymetry. Very useful and seeing both these things at the same time. Next two buttons are if you have a dual head transducer, you can turn on and off heads 1 and 2. And the next group of buttons are your playback buttons, and we'll be going over those a little bit more as we get further into the demonstration. Okay, if you need a little refresher on subset Swath Editor, because you haven't been using it, some of the things you can do is if you middle mouse, it'll control which profile that you're looking at over here in your plan view. You can also adjust the amount of data shown in your plan view by manipulating your profile spacing. To give you a quick example of that, you can see how everything's changing over here in plan view as we move back into the profile spacing. Next new thing you're going to notice is the water column imaging tab. What we can do here is we can control the color map that we're using to display water column data. The one that we've seen seems to be most popular so far is the seismic color range. It does a really good job of displaying water column data. The next thing we can do is we can turn on a stacked view. With the stacked view, what we're doing is we're stacking all the water column images controlled in your plan view and returning the brightest pixel here to your cross-track view. And then in your along track view, we're looking at stacking all of your beams from 1 to your highest beam number and showing the highest intensity returned in the along track view. Alright, our next thing we can do here is we have this min and max intensity range that we're going to look at. Controlling these sliders will filter out the data that's shown in the water column view. On the low intensity range, we're going to use this to remove data not of interest to us in the water column. On the other end, our high intensity ranges are associated with those where we already bottom tracked in bathymetry. You can see as I play with the filter here. What we want to do by establishing these filters in Swath Editor is really just get a ballpark figure of what intensities are most interest to us. What we're going to do is quickly move ahead in Swath Editor so we can take a look right here. Let me make this a little bit bigger for you, and it looks like we have something in the middle here, this linear object. It looks like it could be gas seep. So we're going to try and manipulate our filters so that we're just looking at that data and getting rid of as much other data as possible. And that's the goal that we're trying to achieve in Swath Editor. So now we've got our decibel ranges selected. We're going to go ahead and open up Subset Editor. Subset Editor doesn't look any different than it did before. The only difference you're going to see is this water column tab. Once we have water column selected, you have the ability to load, unload data. We've got increased filter capabilities here. You can filter using a minimum and maximum depth. You can also filter with your minimum slant range, which we're going to leave turned on. We're going to take that -40 and the -20, which we derived when we were looking at Swath Editor, to help us eliminate data. So again, we can see the forest from the trees here. We also have the ability to color by depth, project, vessel, line, intensity, day, and bottom detection. We're going to stick on intensity here, and we're going to go back to that seismic color range. We're going to go ahead and load. And while loading, you still have full capability to your subset editor, like you always have. And then when it's ready, it's going to tell you that you can open it. Scooch this over here. One thing you'll notice down here in the water column tab, you also have the ability to turn on and off water column data, just like you do your regular bathymetry. So let's see if we can't make this gas heap stand out just a little bit better. So it looks like we have this linear object here in our data. We're just going to tweak these filters a little bit on both ends. See if we can't get this data to stand out a little bit better. You can also rotate. I think we can see those gas seams pretty good now. So that is one example of how using water column data can help you along. Our second example today is going to be chart related. So we're going to quickly look at some data. We're going to fly to the other coast of Canada. This data is located just off Vancouver. And we're taking a look at some wreck data. The wreck in question is the GB Church, which was built in 1943 and originally sailed as a supply ship for the Allies in World War II. In 1989, she was sunk off the coast of British Columbia by the Artificial Reef Society of British Columbia, creating an artificial reef for divers in the local area. Again, this data set comes to us from the Ocean Mapping Group at UNB. And just as an illustration, we have a pre-sunk photo of the GB Church below. I'm going to show you the coverage of the GB Church using 24 lines of bathymetry here on the top right. I'm going to take a look at one pass of bathymetry on the left. Keep that in mind as we go back in and take a look at the data with water column added. Again, we're going to use this nice new right-click tool to open up our Swath Editor. All our settings, we're going to tweak a little bit here. Go in and pick the seismic color range again. And we're going to move. What I'm trying to do is here is encompass the entire wreck here, which we can see in the bay surface. Manipulate spacing a little bit so I can get the entire wreck in there. I'm going to go ahead and enable the stack view. We're going to try and create some useful filters here so we can see just the ship data in the water column. We don't want to take out too much data. We're going to be able to manipulate that again when we get into subset editor. The interesting thing about the particular water column image that we're on right now is that you can see right here, this is your bottom detection, but your least depth is way up here. So this is where it can become really handy. We're looking at about 17 meters on your bottom detection. Then we can come up here and we're looking at about 5 meters in your actual water column. So you either need to go back and verify that with more multi-beam or diver or whatever. Very important for chart production to make sure that we're getting that shoal depth in there. Another thing, promised you, we're going to go through these playback tools really quickly. You get the forward, reverse, and also to get to the front and back, and also the play buttons, play forward and reverse. And you can take along here and take a look and see what's going on with your data, whether or not, again, your least depth is showing you, if the water column is showing you a greater least depth than the least depth that you're reporting. So quickly open up subset editor. Zoom right in here. back to water column, and I believe we went about minus 35 and minus 10 with our filters that time. Set our filters. Go back to that nice seismic color range. Coloring by intensity. Load the data up. And there we go. So now we can see that our water column data is now displayed along with our bathymetry, and it's showing us the shoulder depth that we didn't see in the bathymetry. We can come in and we can play with these filters a tiny bit and maybe get this to look a little bit better and have everything stand out. Yeah, I think we get a much nicer looking rec right there. Again, we can come in here, we can turn this line off just to illustrate the difference between water column data and no water column data and how that helps you find your shoalest depth. Again, we can compare here. We've added the water column data as colored by depth to our image here to show how that enhances your bathymetry. Some of the other highlights included in Service Pack 1, including not having to carry over raw data for production anymore. Similar to what we talked about when we talked about converting water column data, lowering the size of your HIPS project. It also includes added support for various backscatter data types. And one addition I really liked is that session files are now saving edits to your geobars. We've also come up with some additions to the CARIS files. Metadata and vertical datums are now read and write in the properties window, so you can make changes to your start and end survey dates, update your comments field, or add a vertical datum to your CARIS files post creation. We also snuck a few other cool things into the service pack. We brought over the profile tool from Bathy database, and this is a great step forward for drawing profiles in HIPS and SIPS. We also have the ability to compute statistics on layers. This command will generate statistics on an attribute layer of a base surface, mosaic, or a geobar. These statistics are reported together with a histogram depicting the distribution of points and nodes within a min-max range of values. You can also calculate track lines by SV profile that's been applied to them if they've been SVC corrected since installing Service Pack 1. The image here below can show you, in this case we use nearest and distance. This green dot here represents one sound velocity profile, and that's the profile that was applied to this section of all these lines. And we have another profile here, this tan colored profile, and that's been applied to this section of the lines. And we have a blue dot down here, and that's showing nearest and distance, but a really good QC tool if you're having trouble with sound velocity data. The other thing we snuck in there is the right-click open line editors, and we already went over that when we were showing the water column demonstration. Keeping connected with CARIS is now even easier. Today's webinar is being recorded, and it will be available for viewing on the CARIS YouTube channel. You can see the URL for that on your screen. Some of our previous webinars are already up, including HIPS and SIPS 7.1 and Bathy Database 3.2 webinars from last year. Also, CARIS is quite active in the social media world, so I'd encourage you to connect with us on other mediums such as Facebook, LinkedIn, and Twitter. If you're interested in attending CARIS training, we have open HIPS and SIPS training courses scheduled over the next few months in the United Kingdom, Australia, and the Netherlands. And check out the link below if you're looking for other dates in your area or for more information on training. Dates are always being added. I'd also like to take a minute to highlight our 14th International User Group Conference. It's being held in beautiful Vancouver, British Columbia, Canada, from June 25th to the 28th. Our user conference is a great opportunity for new and existing CARIS customers to congregate and learn about the latest CARIS software enhancements and workflows. CARIS 2012 will feature boot camps, user group meetings, presentations from fellow CARIS users, company exhibits, and a number of networking events. For more details about the conference or to register, you can go to our conference website, www.caris.com/CARIS2012. And that concludes the webinar.